Hello everyone. Today I am starting chapter Chemical Thermodynamics, and in today's video I'll be talking about what is thermodynamics, what all are the terms used in thermodynamics. Thermodynamics is concerned with the energy changes in physical and chemical transformations. Thermodynamic has no concern with the information regarding the rate of physical process or rate of chemical process or what all are the mechanisms involved in any chemical reaction. For example, the transformation of liquid water into vapor, or solid ice is converting into water, or carbon is burning to form carbon dioxide. All these changes, what is happening in terms of energy in the changes? Chemical processes like chemical energy is converted into electrical energy, or maybe you can say in electroplating of metals, electrical energy is converted into chemical energy. Here in all the processes, energy is transformed into its one form to the another form, and the transformation of the energy from its one form to another form, and the study of all the concern of energy related, we are studying in this branch. Now, some terms related to thermodynamics, and the first terminology which you will come across in this chapter will be system and surroundings. Let's understand with this example, with this figure which is given on the screen. This is one gas cylinder, and it is having one movable piston. Suppose we are studying the change in the volume of gas and the amount of energy released or gained by the gas when pressure is varied by putting certain mass on the piston, right? In this case, the gas is called as system here, because we are studying gas, whether its volume is increasing, decreasing, pressure is increasing, decreasing, and during the increase or decrease of volume, what all are the changes in is happening in the energy also. So this gas is the system, and the part of the universe under the thermodynamic investigation is called system, and this is the definition of system. And all other various part of the universe outside of the system, like the cylinder, the room temperature, the surroundings, everything is called as surroundings. Now, types of system. There are three types of system: open system, closed system, and isolated system. Now let's understand open system with this diagram. Here you have one cup of coffee, and it is open. It is not covered with the lid. Now coffee will cool down if it keep on releasing its heat to the surrounding. Here coffee is the system, and other thing are surroundings. What is happening? Coffee is keep on losing its heat and its temperature is lowering down. Plus, one more thing is happening to this coffee is that water vapor from this coffee is also going to the surrounding. So such system where you will see exchange of both energy and matter. Matter means steam, energy means heat. Such system which exchange both energy and matter with the surroundings are called open systems. Now you have one coffee and you have covered this coffee with one saucer. Now what will happen? Coffee will release heat to the system, so to the surrounding, but matter from coffee will not escape. Such system that exchanges energy, not the matter with the surrounding, is called closed system. Now isolated system. Now you have taken this cup of coffee and you have put in a isolated container. Now coffee will not cool down. It is insulated from the surroundings and there is no escape of water vapor into the surroundings as well as heat to the surrounding. Such systems that does not allow either the exchange of energy or matter with the surroundings is an isolated system. Now, properties of system. There are two properties of system: extensive and intensive property. Extensive property are those property which depend upon the amount of matter present in the system. For example, mass, volume, internal energy, heat capacity, number of moles, these all are extensive property. These property will change if we are changing, for example, mass. If we are changing volume, the extensive property will also change. Intensive property, all those property which are independent to the amount of matter of the system. For example, temperature, pressure, surface tension, viscosity, melting point, boiling point, etc. For example, if you have water 100 ml and if you have 1 liter of water, boiling point of 100 ml of water will remain 100 degrees Celsius and boiling point of 1 liter of water will remain 100 degrees Celsius. So it is intensive property of 100 ml water or 1 liter of water, which is independent to the mass of the water, you can say amount of the water. Now, the next term is state functions. Let's understand with the help of this diagram. You have taken one gas in this container having pressure P1, V1, T1 and n number of moles. Now, you have done something to this container. You have done some changes in pressure. Let's suppose initial pressure was 1 bar and final pressure you have put more, it is becoming 2 bar. So the volume will decrease, then V2 will also decrease, T2 may be decrease and number of moles will remain same. So now this is the final state of the system, which are having what all things? P2, V2, T2 and N. A change in state function of a system bring forth a change in its state. The property which depend only on the state of the system and independent of the path followed to attain it is called state function. Means you have the container with initial state P1, V1, T1 and N. You have done something and you are having now final state of this container having functions like P2, V2, T2 and N. So this is the final state. The property which depend on the state of the system and it remain independent of path. Means from P1 you are bringing this container to P2. This property, this function will not going to think about what path you have taken, what measures you have taken. It is only depending upon the initial and the final state and remain independent of the path following to attain P2, V2, T2 and N. And the term process means a physical and chemical change in a system on going from one state to another state. It may be attained by taking only single step. It may be attained by taking number of steps, or you can say number of path. And path here refers to the sequence of the situations the system undergoes during the accomplishment of change. And the process in general may not necessarily determine the change in unique way. And at the end, I will only say state functions are the function which are usually represented with delta, like delta U, delta G, delta S, delta T, delta V, which are having final value and initial value. Now the next term, which is path function. Path functions are the properties which depend upon the path, and that is why they are called as path functions. For example, work and heat. Another term, thermodynamic equilibrium. Thermodynamic equilibrium, again the same example. We have one gas cylinder having pressure P1, temperature T1, volume V1, and now these state functions continue to remain constant as soon as I am not disturbing the piston, or I am not disturbing the pressure. So no exchange of heat will take place. So this is in equilibrium state. If I am moving piston in upward direction, so gas will expand, volume will change, pressure will change, and it will vary with the continuous movement of the piston. Like if you are moving piston up, the pressure will keep on decreasing and volume will keep on increasing. The gas at that moment will not be in chemical equilibrium state, or it is in non-equilibrium state. As soon as I stop the movement of piston, now at this stage, what is happening now? The gas is attaining pressure P2, volume V2, temperature T1. In that state, now these are the state functions, and now it is coming in equilibrium state. So I can see a system is said to be in thermodynamic equilibrium when its state functions will not vary with time. So thermodynamics considered here considered here is limited to the equilibrium state. Now we'll be talking about some processes. Number one is isothermal process. Process is actually transition from one equilibrium state to another. This is what we are call as process. Isothermal process is the process in which temperature of the system will remain constant, and in such processes heat will flows from the system to surroundings and vice versa, but temperature will remain constant. In isothermal processes, you will always have delta T equals to 0. That is why internal energy of the system will remain 0. Internal energy means delta U. Isobaric process are the processes where you will see the pressure will remain constant. In all chemical laboratories, we used to carry out all reaction in open containers at atmospheric pressure. So delta P remains 0 in all the chemical reaction which we perform. Isochoric process. Isochoric process is the process during which the volume of system will remain constant during the transformation. A chemical reaction carried out in closed container is isochoric. Now, adiabatic process. Adiabatic process are those processes where there is no exchange of heat between the system and surrounding. You can say here Q will always remain 0, and in adiabatic process the system is completely insulated from the surroundings. Reversible processes. Reversible processes, let's understand with the example. There is a gas in a cylinder with a movable piston, and one external pressure which we are considering, it is P external on the outer surface of the piston, is set equal to the pressure of the gas, which is P. Neither expansion nor compression of gas is happening. Then the system is called as it is in mechanical equilibrium with surroundings. The features of reversible process are: number one is driving and opposing forces differ by an infinitesimal amount. Infinitesimal matlab extremely small. The process can be reversed by an infinitesimal change in condition. The reversible process proceeds infinitely slowly and takes place in infinite number of steps. And the last feature is, at the end of every step of process, the system attain mechanical equilibrium with surroundings. So this is all about your features of reversible process. Thank you.